Hello and welcome to the lesson video notes for Chapter 10, Lesson 4, Surface Area of Prisms and Cylinders. Make sure that you are in the Lesson 10.4 portion of your notes. We have skipped Lesson 10.2 for the time being, so make sure we're starting here. Today's objective will be to learn and apply the formula for the surface area of a prism and learn and apply the formula for the surface area of a cylinder. Before we get started, why don't you take a few moments to make sure you have these warm-up questions answered. In just a moment, I will display those answers, so pause the video so you have enough time to complete these. Alright, here's what we should get for our answers for these warm-up questions. For number 1, perimeter of this rectangle is 46 centimeters, area is 126 square centimeters. For number 2, the perimeter is 36, you've got to use Pythagorean theorem to find the other side, and the area is 54 square centimeters. And number 3, the perimeter is 18, because each of the three sides is 6 centimeters. And then, if you use your special right triangle, 30, 60, 90, as half of that equilateral triangle, the height of your triangle is 3 root 3. So your area is either 9 root 3 or, if you rounded, 15.6 square centimeters. All right, let's take a look at the beginning of Lesson 10.4. In this lesson, we cover some different vocabulary terms. In a prism, the lateral face is any face that is not a base. Lateral edge is any edge that is not an edge of a base. So in a right prism, in that case, the lateral faces are all rectangles because the lateral edges are perpendicular to the bases. In an oblique prism, it has at least one non-rectangular lateral face. That's whenever we've taken it and shifted it one direction or the other. The altitude of a prism, altitude kind of means height, the altitude of a prism or cylinder is that perpendicular segment joining the planes of the bases. Most of the time we will be dealing with right prisms, and so the altitude will be along an edge of a prism. The surface area, then, is the total area of all the faces and curved surfaces of three-dimensional figures. The lateral area of a prism is just the sum of the areas of the lateral faces. So if I were to take this triangular prism and make the net, the lateral area is only these yellow highlighted parts, not including the area of the bases. The total surface area just adds in the area of those bases. So this kind of helps you see how we derive the formula for our surface area formula. If we take this apart and look at the net, this rectangle making up the lateral area has a length, or a base rather, of these sides of your base figure. In other words, the perimeter of your base figure makes up that base of this rectangle. The height of your rectangle is the altitude of the prism. So the lateral area is just this total plus the height, or lateral area equals perimeter times the height. Perimeter of your base times the height of your prism. And then the base areas are just the area of those bases. You have to figure out if it's a triangle, a rectangle, a square, or any other regular polygon. So the total surface area of a prism is one lateral area plus 2 of the base areas. So the lateral area of a prism, you'll remember, lateral area we represent with capital L, is the perimeter of the base times the altitude, or the height. So the surface area of a right prism then takes the lateral area and adds 2 times the base area, because there's a base on top, a base on bottom if it's lined up vertically like that. Now a cube is a special kind of prism that has a special surface area formula. In a cube, all 6 faces are congruent squares. So to find the surface area, we just take the area of a square, side length squared, and multiply by 6. So these are the formulas we'll be using in this next part of the lesson. So in example 1, let's find the lateral area and surface area of prisms. Well, we have a rectangular prism. We're going to go ahead and call the base this rectangle on top and that rectangle on bottom. So the lateral area is what we should find first. And remember, that's the perimeter of your base, 9, 7, 9, and 7 are those sides, times the height. Well, that means 14 is the height. All right, so let's find our lateral area first. Lateral area, we're going to take that perimeter, 9 plus 9 plus 7 plus 7. Okay, 9 plus 9 is 18, 7 plus 7 is 14. 18 plus 14 is 32. So our lateral area is 32 times that height measurement of 14. So our lateral area of this figure is 448 square feet. But that's only part of our answer. The rest of the problem asks us to find the surface area. The surface area then just takes the lateral area plus 2 times the base area. Well, in this case, the lateral area we just found was 448, so I'm just going to substitute that, plus 2 times the base area. So I'm going to come back up here and find the base area. The base is a rectangle with one edge measuring 9 feet, one edge measuring 7 feet. So those dimensions multiplied together, 9 times 7, give us a base area of 63 square feet. So I'm going to take that and double it because there are two bases. So my surface area is the lateral area of 448 plus the combined base areas of 126 when you double that. And if I add those together, I get a total surface area of 574 square feet. And we're in square feet because it's surface area. All right, let's take a look at example 1b. We want to find the surface area and lateral area of a right regular triangular prism with a height of 20 centimeters and a base edges of length 10 centimeters. So we would really benefit from seeing what this looks like in three-dimensional form. So in just a moment you will see a picture that goes along with this. Okay, this is what it might look like. Now I've turned it on its edge. Remember, the bases are still the two congruent regular triangles. Right does not refer to the triangle, it refers to the prism. It just tells us that the bases are exactly opposite one another, and the edge of a base is perpendicular to the edge that is not of a base. So this diagram helps you see that these triangles are our bases, and those are equilateral triangles. That's what regular triangles are, equilateral. Okay, it says the height of the prism is 20 centimeters. Remember, the height is the distance between bases. And the base edge length is 10 centimeters. Now, I've gone ahead and drawn just a shape of the base to make it a little bit easier, because here's the things we're going to have to find. We're going to have to find the lateral area and surface area. Lateral area means we need the perimeter of a base to find that. Remember, that's perimeter times height of the prism. Surface area means we take that lateral area, plug it in, and we add 2 of these base areas. In order to find the base area, I have to be able to find the area of that kind of a triangle. Now, I've drawn the little altitude of this triangle to show you, and that would bisect this side. So if this is 5, we should be able to see, remembering this is a 30, 60, 90, if I cut it in half, that this is 10 root 3 for that altitude of your triangle. That's going to help you find the base area for that triangle. So I want you to take a few minutes to go ahead and find lateral area, plug it in, try and find the base area, and then click play when you're ready to check your answer. Okay, we should get something like this. Your lateral area is the perimeter of your base, 10, 10, and 10 make 30, times the height of your prism, 20. 30 times 20 is 600 square centimeters. So we take that and plug it in for our surface area plus 2 times the base area. Well, here I've found the base area for you. The area of a triangle is 1/2 base times height. Again, this is height of the triangle, not height of the prism. That height of your triangle, as we saw, was 10 root 3. The base of your triangle is 10. So I'm going to do half of 10 times 10 root 3. That gives me 50 root 3. So I plug that in for the base area. So 2 times 50 is just 100. So my surface area is 600 plus 100 root 3. And when we calculate that and round to the nearest tenth, we get 773.2 square centimeters. All right, now let's take a look at lateral area and surface area of cylinders. The lateral surface of a cylinder is the curved surface that connects the two bases. If we were to unwrap that, as we'll look at in a minute, we would get a rectangle, but it's technically a curved surface. The axis of a cylinder is the segment with endpoints at the center of the bases. If it's a right cylinder, the axis is perpendicular to your bases. If it's oblique, that axis is not perpendicular to the bases. Think of a stack of CDs that have been shifted to one side. That'll give you an idea of an oblique cylinder. So let's take a look at those formulas. The lateral area of a right cylinder then is going to be, if you were to unwrap this net, we would see a rectangle where the height of the rectangle is the height of your cylinder, but the base of this rectangle is one pass around that circular base. In other words, the circumference of the circle, which is 2 pi r. So remember, lateral area is still perimeter, or in this case circumference, times the height. So lateral area of a cylinder is circumference times height, or we could write that as 2 pi r times the height of your cylinder. Then the surface area takes that lateral area plus 2 of the base areas, or we could write that as 2 pi rh for lateral area plus 2 times the base area, which is area of a circle, is just pi r squared. So in literal terms, we'll just replace it with that most of the time. So let's take a look at using these formulas. Example 2, we started with part C. We want to find the lateral area and surface area of each of these right cylinders. Now, what do they give you here? Well, 16 inches is the diameter. If the diameter equals 16, the radius equals 8, and 10 is your height. So first, let's find lateral area, which is 2 pi r, that's your circumference, times the height. Let's just fill in what we have. 2 pi r would be 2 pi times the radius of 8 times the height of 10. Let's go ahead and give our answer in terms of pi. That means that that's 2 times 8 times 10, which is 160 pi square inches. Surface area takes that 160 pi. We're going to add 2 of those base areas. Well, base area, bases are circles, so that's pi r squared. So we're going to add 2 pi times the radius of 8 squared. So we have 160 pi plus 2 times 64 pi. 2 times 64 is 128. Now, since these are both in terms of pi, they are like terms, and we can combine them to 288 pi square inches. Alright, that concludes the examples we're going to cover in this video. There are some more examples. You could probably try and go ahead and start example D, but we're going to cover the rest of the examples in class, or at least most of the rest of the examples you will see in this lesson. If you want to get a head start on those and try and figure those out by looking at the examples in your book, you're more than welcome to. Otherwise, we'll cover those examples in class, and we'll start the assignment for lesson 10.4 in class together on Tuesday.